Have you ever taken the time and investigated your HVAC coils? Do they look different from unit to unit? Have you ever asked why HVAC coils use copper tubes and aluminum fins? Is there something fishy about the fins? I'm Jason Letterman, and welcome to another Titus Timeout podcast. In this episode, we're going to take a closer look at HVAC coils. We can start with the obvious. Many of us know that coils use copper tubing and aluminum fins. Copper is great for heat transfer, and aluminum, while not as good, is still very effective as seen in the displayed chart. As you can see, when compared to other types of materials, the first goal of any HVAC coil is to cool or heat. Heat transfer is our first concern, followed closely by cost. Copper works well for the tubes, but ends up in many cases too expensive for fins. Many times a convincing reason will be needed for its use. Some cases may be the reduction of galvanic corrosion between dissimilar metals, or possibly used in coastal resilience in marine locations. However, the majority of the coils seen in HVAC equipment are built with copper tubes and aluminum fins. The combination has the most effective heat transfer as well as the lower cost. This may seem hard to understand when fins are roughly 70% of heat transfer in HVAC coils and the tubing makes up the remaining portion. One reason for this is the sheer amount of material in the airstream as well as the fin to tube bond. This bond occurs through tube expansion into the fins. Inadequate bonding with the fins will result in underperforming coils in relation to heat transfer. You're probably asking yourself, what's fishy about fins? Well, let's look at the fish. Different species of fish have different types of fins. Some are small, some are long, some have more than others. The principal function of their fins is to help it swim. So if you happen to look at the fins on an HVAC coil, you may have noticed some difference in size, shape, and design. Each of those differences have a benefit in some form. Over the next few minutes, we will identify 4 types and highlight some of their characteristics and common uses. Our first type of fin is a louvered fin. Louvered fins increase heat transfer capacity through creation of air turbulence, which reduces the boundary layer of the fin's surface. With this design, there is an increased pressure drop through the coil. Therefore, more horsepower would be needed to overcome the pressure drop. Some common applications would be condensers with light dust accumulation and evaporators. Our second type of fin, corrugated. Corrugated fins improve heat transfer, but not to the level of the louvered fin, but does have lower resistance to airflow, therefore allowing lower horsepower motors on the fans. They are commonly found in heavier dust environments or areas where icing may occur. Our third type is called a sine wave fin. Sine wave fins have a heat transfer factor higher than corrugated fins while maintaining the same airflow resistance of the corrugated. This type of fin can be labeled the utility choice for coils, as well as the default fin shape when not specified by engineers. Our last fin option will be the flat fin. Flat fins are good for reducing ice accumulation and tend to have the lowest airflow resistance. This particular fin may be found in freezer applications or in passive airflow systems. As heat exchangers are used in a wide variety of environments, understanding reasons why they require different construction materials and/or possibly fin designs is important. For more information on HVAC coil construction, check them out on the website at titus-hvac.com. Don't forget to subscribe to our YouTube channel, and thanks for taking the time out with us.